Here we have some children going around a playground or carnival ride where they're sitting on balls and they're sort of going around. They're going to swing out a little bit, using some circular motion to figure out what is their frequency of revolution. So we got the kids going around and swinging at 35 degrees. From the vertical, the path rate is 4.2. Notice that there's no mention of their mass whatsoever because it doesn't matter. It doesn't matter what mass you have, it will cancel out. This has nothing to do with this situation. So in order to actually cancel out, we must be able to tie them together. Obviously, there are two main forces acting on them. There is the force of gravity, which would be going, of course, in the vertical direction, and we've got the Fc, which is going in the horizontal direction. And those two forces together are what are creating our 35-degree angle from the vertical. So let's sort of just map things out a little bit. We would have a triangle, something like this, where this is one of the kids sitting on the ball, and the angle is 35 degrees from the vertical. We have our two forces. We've got the Fg, which is vertical, and we've got the Fc, which is horizontal, and those two forces are creating the angle. So obviously we need to use some trig to actually tie them together, and since the 35 is here, that would be the opposite, that would be adjacent, so it makes sense to try and use tan theta. So if I do tan theta to see what's going to happen, the opposite would be my Fc, so that would be mv squared over r, and my adjacent would be the gravity, so that's just mg. As soon as I do that, I can see that my masses cancel out, which is what I want to occur anyway. So if I then rearrange this, I'll end up with v squared over rg. So tan theta is equal to v squared over rg. And I can rearrange this and I can solve for their speed. So I just have to rearrange the expression to solve for my v, so I'll just do tan theta, find that, and then multiply that by rg, and don't forget to square root the value after that because we just want v by itself. So if we do that, we get a v value of about 5.4 meters per second. So that's how fast they're going. So once I have that, then I can use the old expression speed is equal to 2 pi rf in order to find the frequency, which is basically speed is distance times the frequency, which is the variation of dTd. So frequency would then just be the v divided by 2 pi r, and that would give me about 0.20 hertz. So frequency of revolution around the thing would be about 0.2 hertz, so that means it would take about 5 seconds for it to get around just